So let's suppose that we have an elevator with a mass of 2,000 kilograms that is stationary and is a vertical distance of 20 meters above a coiled spring that has a spring constant of 50,000 newtons per meter. Now suppose the elevator is connected to a cable and that cable breaks and the elevator travels downward in free fall. Now we want to calculate the distance the spring compresses. So we have an elevator that's connected to a cable. The cable breaks. The elevator begins traveling downward in free fall. So that means we have uniform acceleration. Now it travels a distance of 20 meters before actually hitting the spring. When it hits the spring will compress and the elevator will stop. And we want to find what the distance of our compression of the spring is. So, in the first step, we want to calculate how long it takes the elevator to go from this position to 20 meters downward. So we find the time it spends in the air before hitting the spring. Then we use the time to find the velocity right before impact. We can then use the velocity to find the kinetic energy of our elevator before impact. And then we can use the kinetic energy to find our compression distance. So let's begin with part A. We want to calculate the time and the velocity of our object right before it makes impact. So we said earlier that the elevator is in free fall, and that basically means we have uniform acceleration going in the y direction. So we choose going downward to be negative, going upward to be positive, and we can use one of our kinematics equations to solve for our time. So let's use this equation. Now, let's suppose our initial displacement is 20 meters, our final position is 0 meters, and because our object is stationary, our initial velocity is 0, so v naught is 0. So this term becomes 0, this term becomes 0, this is 20 meters, and because we choose going downward to be negative, we have negative 9.8 meters per second for our acceleration. So we plug those values in and we solve for time, and we see that our time is approximately 2.02 seconds. So this is how long our elevator spends in the air right before it makes impact with the spring. Now, let's use a second kinematics equation to solve for our final velocity of the object. So this is what we're trying to find, the final velocity of our object along the y-axis. Our initial velocity we know is 0. Our a is 9.8 meters per second squared. Our t is 2.02 seconds. So we plug those values in and we find that our final velocity of the elevator right before impact is 19.8 meters per second. Now, this a should actually be negative, and so that means our velocity would be negative, and that makes sense because going downward is negative. So this is the magnitude of velocity, and now we can use the magnitude of velocity to solve for our kinetic energy of the elevator right before it makes impact. So we use our formula. The kinetic energy is equal to 1/2 mass times v squared. So we know what the mass is. We know what the velocity is, we just found that, so we plug our values in and we find that our elevator right before impact has the following kinetic energy. So 392,040 joules of energy, of kinetic energy. So this is the amount of energy that the spring must do on the elevator to stop that elevator. So let's calculate the compression distance, what we're actually calculating from the beginning. So now this is the tricky part. Notice that the spring does work on the elevator to stop the elevator, but it also does work against gravity. So when the elevator is traveling and when the spring is compressing, there are two forces acting on the spring. The force due to the elevator and the force due to magnitude of gravity. So that basically means that not only is the spring working against the kinetic energy, but it's also working against gravity. So that means we have 1/2 kx squared. Our work done by the spring for a non-constant force is equal to the kinetic energy plus the gravitational energy. So, which is given by m times g times x. Because remember, the force of gravity is constant, so that means we can use our equation, work equals force times distance, where mg is the force and x is the distance. So we plug our knowns in and we see that we have a quadratic equation, and we use our quadratic formula, we get two results. We use only one result, and we use this result, 4.37 meters. So we use the positive result, and this result means that when the elevator hits the spring will compress this distance, a distance of 4.37 meters.